Hallå och välkomna tillbaka. Nu är det dags för Lars-Inge Sjöqvist på Gapwaves att hålla en presentation. Upplägget är precis som det har varit tidigare. Det kommer vara ungefär 30 minuter presentation och under den kan ni skriva frågor i YouTube-kommentarerna som jag sen kommer lyfta med Lars-Inge under en 10 minuter lång frågestund. Så Lars-Inge, varsågod.
Tack så mycket Magnus och tack så mycket Erik Penserbank för att vi får komma hit och presentera Gapwaves. Jag tänkte inleda idag med en liten film här och sen kommer jag också gå över till engelska när jag pratar för att jag har lovat att vi har en del utländska lyssnare också som ville vara med. Men vi startar med filmen.
Imagine a world where wireless communication has the performance of fiber optics, bringing people closer together, making transportation easier with autonomous vehicles completely aware of their surroundings, devices that seamlessly communicate and collaborate to make your life flow better. At the center of this scenario is the device responsible for the sending and receiving of all the data, the antenna. To enable true 5G communication, we need to operate at a much higher frequency than today. And as the frequencies increase into the millimeter waves, the performance requirements for the antenna increases tremendously. At Gapwaves, we have a groundbreaking new way of designing and manufacturing antennas, holding the key to enable this future of high-frequency communication. Today's 5G antennas are based upon traditional PCB technology that require a lot of energy and yet have a very limited range, meaning a higher antenna density. Hence, scaling up 5G with today's antenna technology would have an enormous environmental impact and would crowd our urban areas with big antennas. The automotive industry races towards safer mobility and semi-autonomous vehicles by using advanced radar technology. But the market has a hard time supplying the demand of high-performance, affordable, and reliable solutions. But we hold the key, a totally new approach to designing and manufacturing waveguide antennas, bypassing the previous high requirements on tolerances and complicated processes. With Gapwaves technology, we create antennas that are cost-effective, scalable in mass production, and combining the range of 4G with the speed of 5G. Within telecom, our antennas would double the range, allowing for coverage not only in urban areas, but also in the countryside. They would only require a tenth of the energy consumption compared to traditional PCB antennas, leading to a significantly lower environmental impact. Simultaneously, it reduces the requirements of all other components within the antennas because of the lowered heat emission. The future benefits of 5G-enabled vehicles are vast, but our antennas also have positive implications from a safety aspect if applied to radars. Our antennas can double the range and increases the field of view of radars in providing far higher resolution and details. This allows for a compact design, which is easier to build into the vehicle and enables enhanced safety features to not only be a premium car feature moving forward. With our antennas, autonomous vehicles would be safer, no matter the lighting or weather conditions. To increase the frequency and meet the requirements of 5G, the industry is looking into waveguide antenna technology, basically a metallic rectangular tube in two halves through which radio waves can travel with low losses. The electrical and magnetic fields from the wave induces electric current along the walls of the waveguide, resulting in high requirement on tolerances to avoid power and efficiency loss. Gapwaves replaces the method of using metallic walls with a metamaterial surface called an artificial magnetic conductor. A unique structured surface consisting of pins has the similar effect to a perfectly sealed wall, completely preventing the waves from propagating in undesired directions without even having to have contact around the waveguide. This allows for an effective waveguide to be built with dramatically relaxed tolerances, meaning it can utilize existing manufacturing technologies. This groundbreaking artificial magnetic conductor was invented in 1988 by the Gapwaves founder, Simon Shieldall. His invention was clearly ahead of his time, but now that the wireless technology has caught up and is actually requiring this invention, we have a production-ready solution in the midst of implementing it into the massive and complex world of automotive and telecommunication. We are on the doorstep of the future, and we hold the key.
Yes. So that's a small, short introduction, and that film you also can access directly from our homepage, of course, or if you Google on YouTube, you will find it as well. And it also gives a very interesting view of what we really are doing with this company and the technology, the invention we have made, or Per-Simon Kildal, who is the inventor, made many years ago. So this company was founded 2011 by just Per-Simon Kildal, and at that time he worked for Chalmers. He was a very well-known professor working for many years in Göteborg, but he also were on many big conferences in the antenna communities around the world. So he was keynote speaker quite often. To finance this company, when I met Per-Simon some years ago, it was like 2014. We started to discuss could we make this happen, and then we decided to go for an IPO on the stock market. That's a good way for us to get in more money, because you need money to build this kind of company, having an interesting invention in the back. And 2016 in November, we started with an introduction to Nasdaq First North. At that time, we had a market cap or market value around 50 million pre-IPO, and today we are up in the level of almost 200 million euros. But there is also a number of shareholders in the company today. We are more than 8,000 shareholders, so it has been growing quite dramatic over time. And that's good, and we have many people looking what we are doing and are interested in our technology. For this, it's important to say also that this is patented technology. Today we have around 30 different patents. It's over 30 patents families we have in our portfolio. But we started with one very important part with this pin structure, this meta surface idea of Per-Simon. That's the hard thing in the bottom. So everything based on gap technology, also based on our patent, if you see something else on the market. But still we are very much alone on this area, and that's good. So it's a security to have this kind of protection with the patents, of course. The company is specialized in antennas, not the PCB as you are maybe seen quite often in different products. You will see a PCB antenna. We are doing what we call waveguide antennas, and that's the major thing. And the reason for that I will come back to. The company is specialized in telecom, but also more and more into automotive. And automotive radar has been a very attractive application for us, because the customers here are very keen to get in better antennas for their solutions. But we also work with 5G. And the technology as such it's something unique. We are the only one who can really produce this kind of things or design them. If you go to our competitor, there is only one on earth. So we are two companies currently on that market today doing this kind of waveguide antennas. Some word about the frequencies. I think we saw this before when Anders Storm, if you were looking earlier, did show something similar. And the frequencies used in different areas like 5G, for example, or in automotive radar are different. And the reason for that is, of course, that you need a different spectrum, which is owned by your own, or you can use it free. So that's the reason for having different areas. Typically, we see most 5G and 4G and 3G coming up in the level of up to sub-6. We talk about 3 to 4 gigahertz as the highest today. But we really don't make sense with our antennas before we are up in like 28, the millimeter wave arena. So coming to the next thing here is that automotive industry has as a standard, a global standard, 77 gigahertz for all the radar applications on Earth. So that is a very hot and very interesting area because our technology is increasing in need when you go up in frequency. So that's higher frequency, more interesting for us to come in with our technique. In the film you just saw, we showed a little bit about this waveguide. What is a waveguide? Yeah, it's really a channel that you can propagate your wave, electromagnetic wave. And you want to do that without any leakage. And to prevent this leakage, we use, instead of sealed walls in metal, only pins. And these pins are made in metal, but they could be made by plastic, and you put on metal on top of that. So you see here typically how the structure is built inside an antenna. And this is a good way for production. It's easy to produce if you compare with the classical, so to say, waveguide solutions on the market. On this picture, you can see a typical waveguide in the corner here. The yellow line here is really something you can see as a rectangular waveguide, it says here. That's typically how you build a waveguide. And the geometry inside that metal should be exact. Otherwise, you will not have the right propagation of the wave. And if we do it with our technique, we can make it much easier, much cheaper. And the other way to do it is really to go for these PCB-based antennas. But they have one big problem, and that's the losses, because the losses with the PCB antenna is increasing over the frequency. So if you are up in 77 gigahertz, which is, as I said, the typical automotive industry, it's almost difficult to get anything out from an antenna if you use a PCB. So in that case, the waveguide solutions is very much and in need for what you need to see on the market. So this is typical things which we see every day today, and the customer is really happy to see what we can provide for them. Today we work in these three areas. It's not only telecom and automotive radar. We also have some new verticals, but we produce antennas ourselves, but we also produce quite a lot of prototyping to show our customers what is possible to do with our technology. So this automotive radar, that's typical things you are using in cars. Today we have probably one radar per car, and what the market is looking for the coming years is that you will have at least 5. We talk about corner radar, front radar at least. There could be also side radar in the same car. So this means there will be a big volume of this kind of stuff on the market. And other new radar verticals we are into today is like last mile delivery, robots. We also work with some areas we can see that they will use them for drones, etc. But this is a little bit more futuristic projects, I would say. In the telecom, we today have some customers. One is a US-based company, and they are very much into what we call a repeater, 5G repeater on 28 gigahertz. That's a phased array antenna, and it's special built for them to use in what I will see, call it fixed wireless access applications mostly from the beginning. But at the same time, we also see that 5G on millimeter wave is not so far in time yet. We will see more coming up the coming years, but so far we haven't seen so much in deployment of this kind of technology. I think you have heard that from previous speakers as well. 5G today is very much on sub-6, on low band, mid band. That's typically what we see mostly. But it will come, 5G on millimeter wave as well. It will take a little bit longer time. We also have some customers testing our equipment or phased array antennas in both Japan and also in Korea today. So our products are out there, but we don't see really that they are going for full production yet. Some more word about what you can do with a 5G solution based on our antenna technology. The good thing is that having low losses, maybe it's easy to understand, but that means you will have a better performance from your antenna. You will have a longer range. You are with the lower loss, then you can have the distance in between the base station and, for example, a house. If you go for fixed wireless access, you can have a longer distance in between them. But still, on mmWave, it's always important that you look for what you call line of sight. So you can't go through a house with the waves of a mmWave application. That's maybe important to mention as well. So it will never be too long distance you need, but you need better distance than you can have with these PCB antennas, we know. And we talk about the performance increase with 2 to 5 times if you go with our antenna technique today. We know that, and that's tested. And our customers, the customers you very well know, working with this kind of equipment, knows this very well as well. On the radar side, I just want to say that we do really have a major impressive performance thing here. This is word from customers who have tried with PCB antenna and also compared it directly with our antenna. And they say they can have 3 dB better system gain in the system. That means like 5 dB gain, sorry, but that means 3 times better performance. And that could be used for resolution, it could be for range, and it can also be for reducing the size of the equipment. So it's very impressive for them. And we know that automotive radar is really an application that our technique makes very much sense already today. Some word about the market. We do have customers. All of them we are not allowed to tell you about because they are undisclosed. They don't want us to tell their name, but some of them are official. In the middle you see one of the first in the automotive area was Veoneer. They signed an agreement with us already 2019. We expect them to have products on the market like 2023 or maybe 2022. But they have just a license, and we will be paid in royalty when they are starting their production. They do the design work themselves. Another big customer in that area is Hella. They designed it this summer in June to go for Gapwave technology fully. And they also are investing in the company like 180 million. So they are both an investor but also a very big customer in this area. Other companies working with automotive radar is Continental, Bosch, ZF. You also have F-Type from US and Denso from Japan, to mention some of them. We have Magna also based in Canada or in US. These companies I mentioned now, few you can say, but it's like less than 10 companies. All of them have the full market of today for all radars, and we talk about like 80 million this year units sold worldwide. So these 8 companies together have the full market. And we have an ambition going for 50% of the market share for the full volume of antennas for this kind of equipment coming years. Not yet, because they are just now doing what they call, we heard that word before, design win, but they are designing in our technique in their products now. That means it will be on the market 2023, 2024 earliest. On the mid side here, we also see some other customers in the area of traffic management. We have Smart Micro. They also make radars for having in conjunctions, etc., to help the system or the smart city really to balance the load on the roads in a good way. This is something also happening now. We will see more and more of radar equipment also in conjunctions. You have road and train, for example, so we don't have any hinders coming up, which is not seen. So the radar application will be more used in a lot of different areas, and we are into them. Another big customer for us is Under. They are a chip provider. They have made, I would say, one of the best chips for radars today. They have a very competent radar chip. And they have today, together with us, 3 different cases going on. And the end customer in these cases are quite big and very well-known companies, I would say. So it seems very exciting for us at the moment, really. On the telecom side, we have already met all of the customers you see here. And all of them also know what they can do with our technology, so that is known for them. But still, as they say, we can't deploy so much on 5G 28 gigahertz yet, so the time will come. We have to wait until the market is there, because it's not the market yet for 28 gigahertz full build out, I will say. Okay. Another area is these new verticals, we call them. Typically, we find here, I mentioned before, the 5G area as well, but there are also higher frequencies coming up now for this kind of equipment in the research project we are running together with. For example, Chalmers is one, of course, big research center we are working with every day, I would say, but also some EU-funded other projects coming up there as well. So it's also on the satellite communication, taking down the signals from satellites like you have seen today, maybe from Elon Musk is building something big, very network on Earth with something like 40,000 satellites. All these kind of equipment need to have something on ground to take hand of the information. And this is kind of research projects are mostly in that area. But we also see the opportunity for 5G, of course, and we know that both in South Korea, there is one very big company, you can imagine which one. They really are saying to us that the day we are expecting the 5G millimeter wave to grow, then we need your technology. But before that, we have to wait. So it's still a little bit in a balance, I would say. This is the new trends I was into. I just want to say some word about them as well. Here we have interesting customers on the list, of course. And they are working with very much in the area of maybe it's from this e-commerce side, but it's also to do the last mile delivery in a better way, cheaper. And they want to do that with robots. And it's one of the major trends that you should make what we call autonomous vehicles in this area as well, to deliver to us as private person, but also to companies without a chauffeur. That will happen. There is also warehouse logistic for this kind of equipment. We see that there are also a big use for both the, not at least the radar technology, but it could also be the 5G development coming up here. And as I mentioned before, traffic management is a very interesting area, which will grow over time to make the cities much more efficient. You don't need to have this red and green light. You can have a smart introduction into these cities that you can really steer every car. Not at least when they are autonomous, they can all run without any chauffeur and they can run in a system, so to say. That will happen. That's my view of the future. Some breakthroughs, I have mentioned them already a little bit, but coming back to them because they are very important for our company. We made this license and service agreement with Hella. That's the last big deal we made. They also invested in the company in a right issue, 182 million SEK. We do have a license agreement with Veoneer since before, and this is also something which will continue, and we are waiting, expecting volumes to grow. You might have heard that Veoneer is also under some maybe they should be bought up from a company called Magna, which is one of the major players in the automotive industry, or Qualcomm as another buyer or purchase of the company. This is exciting, interesting, and there are, of course, interest to be even bigger in this area for the automotive tier ones we see. And all of them knows us quite well, so I don't have to go into that. The chip supplier, we work directly with them as well, and that's more for showing what you can do with a waveguide antenna compared with a patch antenna. So all of them wants to see and show what they can do with their radar chip together with an antenna from us. This is also, of course, good for our development. And that makes me quite safe that our technique will absolutely become, I say it's sometimes a standard in this area, but that's a big word. It might not be the standard, but it will be at least 50% of the market over time. And these new radar verticals, we don't know, but there will be a number of different new things coming up. You talk a lot about what we call imaging radar. That's a bigger aperture to an antenna that you really can see the view more like a picture from the radar echo. If you compare with just having a distance and some measurement coming out from these small corner radars which we use today. This area is expecting to be growing like up to 30% of the market already 2025. The 5G, yeah, it's very much in the evaluation phase for the 5G, and it's mostly on the 28 gigahertz we have been working so far. But our technique can be used, of course, in 39 gigahertz or in 47, which is other bands they are waiting for to deploy for 5G and 6G. And also a word about production. Today we have produced for Under, that's the customer in US we are working with, a radar application. It's an imaging radar. We have produced 12,000 units at the moment. And this is also important to show that this is really possible to make. So it's produced with some sub-suppliers, but also in our own factory or our office in Gapwaves. We do the assembly and the measurement of each and every antenna. They all have an identification, so you can go back and see from the database which antenna, the performance, etc. So all the 12,000 are, so to say, stored also in the database, which is another part of the production, of course. Hella, some extra word about that. I'm very happy for this agreement together with Hella. It's a license agreement, meaning that they can use our technique in all their products if they want. They have to pay initial, what we call investment, but they also have to pay royalty per antennas sold to the market. So it will be something over many years delivering economic revenue to Gapwaves. In this deal, we had to make a small limitation, and that's an exclusivity on specifically corner and side radar. And maybe that could think, some people think that this will decrease our possibilities to grow the company, but I would say from that time in June, this happened, the interest for what we are doing is really much growing all the time. So all the automotive suppliers in this area has really been growing in interest after that. So for us, it's very much about more insight into this kind of technique, what is important for automotive radar. We learn quite a lot, and we have a very good relation with Hella. So I see it as a very positive thing for the company, and we also have secured our finance for many years. I dropped this one because I already said the most there. I go to the last slide, just say that this is the reason why we think you should invest in Gapwaves. And yeah, we are in a position that we have a very big interest from huge customers. We are in megatrend areas like autonomous driving and 5G. We have a patented technology, which also makes it not so easy to compete with us. And we are in the situation that we already know that we can make this in high volumes to the right price. So I think it's time for rounding off here and come to the question part.
Yes, super. Thank you a lot, Lars-Inge. We have some questions from the web. First of all, is there any other segments that you think you will grow in the future except for automotive?
Yeah, we will grow in all areas that we see that our technique really make difference.
And if you look at the sort of a timeline for telecom, do you approximately?
As I said, we are producing some prototypes, and we have customers, not specifically in US, who test our equipment at the moment. It's made for them, so to say, and they have an idea of going out with a 5G portfolio of products in the area of 5G. We don't know how quick it will work, but they are on the same market as like Sivers EMA with this fixed wireless access, etc. So it's typical competitor to them, I would say, using our technique in this case. So it could happen this year, could be next year, maybe the year after. We don't know.
Yes, and some people have written about the Hella cooperation. And do you think there will be a possibility to form new corporations like the ones with Hella in the future, or are you satisfied with Hella?
No, of course we will make more deals. We are already quite deep into, I would say, 4 other automotive customers at the moment, and they have different niches they are interested to go. Some of them are very much into what we call an HD radar, imaging radar. Some of them are more to this classical front radar. So the corner radar is not all for all, I would say. Some companies will be very good in that, and some will be good in other things. But they can use our technique as well. And from Hella's side, I can say that they have not been trying to narrow us down too much. They want to have some kind of advantage in being a part of the company, but they don't want us to stop everything else. Absolutely not. They are quite business-minded, I would say.
Sounds good. And also we have a question regarding Tesla, who is using cameras now instead of radar. Do you think there will be a threat from that area that more will take after Tesla?
I can say that the person who read that article should read it to the end, and it will say in the end that there will also be radars in the cars. So it's not only cameras, because if you compare a camera or, for that instance, a LiDAR or a radar, they all are good in sensing, of course. But the cameras and the LiDARs have the problem with if you have sunlight coming directly into the lens, or if you have fog or too much snow, for example. The radar don't need any light. It don't have any problem with snow or rain, and it don't have any problem with the sun coming just into the radar. So it's a more robust sensor, and if the sensor of a radar can be in the same capacity, so to say, as a LiDAR or a camera, it will be that one you will use. Even what Elon Musk is saying, I don't think that is the right sense he is looking for. There will be radars in all of these kind of equipments, also in Tesla. It is already.
Yeah. Okay. Super. And we have a question about automotive. It looks like it's going to be mainly license revenues, and I know this will be a hard question to answer, but do you have approximately a figure for the level of the license revenue per car?
First of all, it depends on how many radars there will be in each car. And I will say that the radar as such, it will be a product in the range of 250 to 350 SEK each, if you look for the small ones. An imaging radar could be up to maybe 5,000 kronor, so it's a much more expensive product. And the antenna normally could be some kind of percentage of this if you have just an easy comparison. So there will be numbers, but you should remember that we are talking of full volume 2025 on the level of 300 to 400 million units per year. And if we are able to go for maybe not 50%, but 40% of the market with the big one we already have on board, it will be quite a lot of money in that as well. But I will not say exactly what the price is, because I don't know fully.
Okay. But it sounded like 1 krona, someone speculated here, is quite low.
As a license, maybe.
Yeah. Okay, super. And also we have a question regarding the way you are making radars, especially pertaining to, excuse my Swinglish, but formsprutning and metallisering. And they ask if that's something that needs to be done to create these radars at scale, or how is it?
The way we have decided so far to develop and produce the equipment, it's injection molding you are into for plastic, and on that we put on metal, and then we put these layers together in what we call an ultrasonic welding system, and on that we make the measurement afterwards to see that every single antenna element is working. This is one way to do it. That could be our ones, but we are looking for the cheapest way to produce, and that's something we are running all the time. That could be our ones, other solutions. You can go for die casting, then you have the metal from the beginning into this, but it's more complicated to make that with these currencies. You need to have some quality really on the product, otherwise you will not have the solution or the performance you're after. And the plastic molding is very good for this, we have seen and learned so far.
Yeah, and is that patented in some way, so they need to pay you a license if they do it the same way? Or
the patents is not 100% related to the material, but there could be different production methods we have also some patents on, and not at least the testing equipment when you measure each antenna to see that it works. Because you can't send that to the customer and say that you should put that together with your radar, etc., and build it together, because it's too expensive if it not works then. So you have to know that the antenna is working before you send it to the customer. And if you are in this field, RF field, you will understand that this is not so easy. This is quite tough to understand and learn.
Yes, and we have another question regarding when will you sell complete products with both antenna and chip?
Okay, that is not anything we have decided yet, but we do have questions from customers who ask for a full sensor. So we see the business case and an opportunity to go for a full sensor, absolutely. But then we also need more people, especially in the areas of signal processing, software development, and also the electrical structure of a PCB, etc. So we don't have that competence fully in the company today. We are focusing on the antenna, which is a physical product still. But the possibility is there, so it could be something for the future.
Yeah, and regarding that area, in the future, will you produce in-house or will you do it by outsourcing when you go up to scale?
On high scale, I don't see that we will make it in-house, because that will be also spread out on Earth. We know, for instance, from Hella, they already have told us they will start with our supplier we do have in Malaysia, China. It's Franken Group, and make the first line and start the production. But they will also copy this one on more places, because they want to spread the production on more sites, so to say. It will be in Europe, it will be in US as well.
Yes, and the shortaging of chips currently, how is that affecting you? Can you reason a little bit about it?
As we are in a quite early phase and the full production is not going on, we don't see any problems in that area at the moment. And on our, there could be some delays on some deliveries, yes, but it's not much. So far we have not been affected, I would say. It could happen over time, but not yet.
A thought I've had there is that your technique will be more common in the future, and if you don't buy a car today, you will probably need to buy it in the future. So maybe it could even be something that is good for you, if you see it that way.
You said something car now. I missed your question a little bit.
Well, never mind. We can go to the next one.
Okay.
You mentioned that you have one real competitor. How are you similar, and what are you doing differently?
They make they make a waveguide antenna, but with a traditional method. They have to do these tubes fully metallic inside. They can't have the pins, because the pins is our patent, and the pins makes the structure much more robust and easy to produce. If you should put a waveguide together, otherwise you need to have what you call a soldering phase in between, and they use also plastic with the metallization. That means that they need to warm this one up again and put in this layer with this soldering. And it's a quite complicated way to produce things. And if anything is wrong in the geometry inside, you have to measure that. And you can only measure it, you can't see it. Then the antenna is waste if it's not working. And that will happen quite often, I would say. But they are there on the market, and they are very strong. It's a company from Switzerland called Huber and Suner. And we know them quite well. We have discussed with them as well over time. So, but I'm confident in our technique, absolutely. And we know that this is really something which is what companies want to do when they go for waveguide antennas. And that will happen.
Sounds like a good note to end on. Thank you, Lars-Inge. And thank you at home. We'll be back in 10 minutes. Thank you.